Hello everyone, this is Rashmi Singh. Welcome to my channel. Structure of atom. In this video you are going to learn about what is an atom, discovery of subatomic particles, electron, protons and neutrons, atomic models by various scientists, and properties of subatomic particles. To know atom, we must first know what is matter. Matter is anything that has mass and occupies space. All things around us, be it solid, liquid or gases, are matter. So atom is the smallest unit of this matter. Like our body is made up of cells, all non-living things are made up of atoms. Many scientists study atom, but the first scientific theory about the structure of atom was given by John Dalton in 1808. The main postulates of Dalton's atomic theory are: all matter is made up of very small and indivisible particles called atoms. Atoms can neither be created nor be destroyed. The atoms of an element are alike in all respects. Atoms of respective elements combined in a fixed ratio to form a molecule or compound. For example, two atoms of hydrogen combine with one atom of oxygen to form a water molecule in a fixed ratio of 2:1. Atoms take part in chemical reactions. Later, Dalton's theory was disapproved as it was found that atoms are divided into subatomic particles, that are electron, proton and neutrons. Electrons were discovered by J.J. Thomson. Protons were discovered by E. Goldstein. Neutrons were discovered by James Chadwick. Definition of an atom. An atom is the smallest particle of an element that exhibits all the properties of that element. It may or may not exist independently, but takes part in every chemical reaction. Discovery of electrons. William Crookes, a British scientist, noted that gas are ordinarily poor conductors of electricity. However, when a high voltage of 10,000 volts from an induction coil is applied to a tube filled with gases at a very low pressure, the gases become good conductors of electricity and begin to flow from cathode to anode in a form of rays. These rays are called cathode rays. Later, J.J. Thomson studied cathode rays and performed discharge tube or cathode ray tube experiment. J.J. Thomson cathode ray tube experiment. As you can see in the picture, in this experiment, a hard glass tube is fitted with two metal plates called electrodes. One is anode, the positive terminal, and the other is cathode, the negative terminal. You can see the cathode and the anode. It has a side tube to pump out gas by using a vacuum pump. Conclusions of this model. Cathode rays travel from cathode to anode in straight lines. They cause a greenish-yellow fluorescence on the soda glass screen placed in a tube. You can see in the picture. They are affected by electric field, that is, they are inflected towards positive field and deflected from negative field. This shows they carry negative charge. These negatively charged particles are called as electrons. Electrons have both definite mass and definite electric charge. The ratio of the charge to the mass of the particles remains the same, that is 1.76 into 10 to the power 11. As the atoms are found to be electrically neutral and the electrons are negatively charged, atom must contain some positively charged particle to make it neutral. This led to the discovery of protons. Goldstein noticed another set of rays traveling in opposite direction to that of cathode rays, that is anode to cathode, when perforated cathode was used in the above discharge tube. These rays are called as canal or anode rays. You can see in the picture the perforated cathode means cathode with the holes. When a high voltage current is passed through the gas taken in the discharge tube, electrical energy breaks up the atoms of the gas into negatively charged particles electrons and the positively charged particles protons. After the discovery of electrons and protons, J.J. Thomson proposed plum pudding model of the atom. As you can see in the picture, according to this model, an atom is considered to be a sphere of uniform positive charge and electrons are embedded into it, like the plum in the pudding. The mass of the atom is considered to be uniformly distributed. Discovery of nucleus. In 1911, Lord Rutherford performed alpha particle scattering experiment. In this experiment, he directed a stream of alpha particles towards a very thin 1/millionth of a centimeter gold foil. As you can see in the picture, most of the alpha particles pass straight through the foil. But some alpha particles are slightly diffracted from the straight path. And very few alpha particles are either deflected by a very large angle or completely bounced back. Rutherford's atomic model. According to this model, most of the space in atom is empty as most of the alpha particles pass through the foil without deviating from the path. There is a positive charge mass at the center of the atom known as nucleus, in which the entire mass of the atom is concentrated. As alpha particles approaching the nucleus get deflected, this proves nucleus contains protons. The size of the nucleus is very small as compared to the size of atom. The electrons revolving around the nucleus in a circular orbits, just like planet revolves around the sun in our solar system. The force of attraction between the negatively charged electrons and positively charged nucleus is counterbalanced by the centrifugal force acquired by the revolving electrons. Drawbacks of Rutherford's model. According to the laws of electrodynamics, if an electrically charged particle is in the motion, it will radiate or lose energy. as a result of which it should gradually pull towards the nucleus and end up colliding with it, as you can see in the picture. This should result in the total collapse of the atom. Rutherford's model failed to explain the stability of atom. Bohr's atomic model. Niels Bohr explained the stability of atom. According to his theory, the electrons revolving around the nucleus are confined to a fixed orbit called shell or energy levels, each of which have a fixed amount of energy. While revolving around the nucleus, electron neither loses nor gains energy. These energy shells are named as K, L, M, N and so on, as you can see in the picture. Discovery of neutrons. We know that an atom contains electrons and protons, and the atomic mass of electron is quite negligible. Therefore, an atom of helium which contains 2 protons should have a mass of 2 AMU, but its mass was found to be 4 AMU. It was therefore proposed that the nucleus of an atom must have another particle. In 1932, James Chadwick discovered neutrons, which do not possess any electric charge, that is, they are neutral, but have a mass equal to the mass of protons. Properties of protons, neutrons and electrons. So you can see that protons is denoted by symbol P or P plus, have 1 positive charge and 1 AMU mass. Neutrons represented as N or N0, 0 charge and 1 AMU mass. Electrons represented as E or E minus, has -1 charge and 0.0054 AMU. Thanks for watching. Please do like, share and subscribe.